Okay, I'll try and keep this video quick because I know that there's probably things that you would rather be doing. But what I'm going to do is I'm going to go through a couple of things to do with circles because that's sort of a refresher on what we were covering last class. We didn't have a whole lot of time to talk about circles, so I think this would be a good opportunity to just go over it and revise and make sure we got everything down. Now, hopefully, before this, you listened to the circle song, and I find that incredibly catchy and a good way to remember it. But there are a couple of things to do with circles that I want to take down, and you'll find this is the same in the worksheet in the workbook. So I want radius, diameter, circumference, which is the same as perimeter, keep in mind, and area. And I'm going to do the same for both of these, but I'm just going to do the letters because I can't be bothered writing them all out. You get the idea. All right? This first one, we have the distance across the whole circle being 10 meters. So that's our diameter. So I can fill that in straight away, and then remember that half of the diameter is the radius. All right, so halfway from the edge of the circle to the middle of the circle is the radius, which is only half the diameter. Now, circumference and area have two different formulas. The one for circumference, you can either use, I'll just write them over, I'll write them here. You can either use 2 times pi times the radius, or you can just use pi times the diameter, right? Either of those is fine. So in this case, I'll just do pi times the diameter. So you can punch that into your calculator if you want to. You know, I've got a good memory for what pi already is. So pi being 3.1415 times 10 is going to give me 31,415. Oh, not squared, sorry, that's perimeter. Okay, so that's the perimeter, so pi times the diameter. Cool, we have that. And for the radius, it's pi, sorry, did I say radius? For the area, it's pi times the radius times the radius times the radius. So pi times the radius squared is another way to think of it. So the radius in this case is 5. 5 times 5 is 25. So 25 times pi, whatever pi is. You put that into your calculator, which I'm going to quickly do just to get a good idea. My calculator app will open, that would be wonderful. And a good way to check that you've got this answer right, if it's 25 times pi, you know it should be slightly higher than whatever 3 times 25 is. So 3 times 25 is 75. So if I've done this right, it should be a little bit higher than that. 3 times pi, well, so 25 times pi gives me 78.54, sorry. 78.54. Right, and that's centimeters squared. All right, so that's the area. So I'm going to do the same again with this circle here now. So we have radius is 8 centimeters. We've given that from the start. If the radius is half the diameter, that means the diameter is double the radius. So I'm going to double 8, which gives me 16. Now again, I'm going to do pi times the diameter. So the diameter is 16, so I do 16 times pi. Which gives me 50.3. 50.3 centimeters. And now I can do the area, which is pi times the radius times the radius. So pi times 8 times 8. 8 times 8 gives me 64. So I can do 64 times pi. 3.1415. And that gives me 201 It gives me 201.06 if you want to go into, depends on how many decimal places the question asks for, but 201 is acceptable for that too. Okay, so that's circles. So that's what we did last class. Now we're going to talk a little bit about volume. Now volume seems to be, apologies, getting stuffy nose. Volume is one that people tend to find a little bit harder, even though it's very similar to area. So for context, if we're talking volume, we're talking about the area inside of a 3D shape rather than the area inside of a 2D shape, which is what regular area is. All right? And all you have to do to find volume is identify what is the main shape that runs through the whole thing. And the best way to do that is to think of it like if it were a cake and I cut it down the middle, what shape would be in the middle, right? And you want to go for, I guess, the shape that is consistent the whole way through. You know, if I cut this through the middle, this shape here, it'll be a star. If I cut it like down here, it's not going to be, it's going to be like wonky and not nice, right? So the star is the face. That's what we're looking for. And you need to do the area of the face or the area of the cross section. We're going to put area of CS times the height or the depth, right? Depending on whether your shape is laying down or standing up or whatever you want to do. So basically the area times the other number, right? So in this case, my area is 12 times my depth is 8. I've done a poor job there because that should be 12 centimeters squared. So 12 centimeters squared times by 8 centimeters gives me 12 times 8 is 96 centimeters, but it's not centimeters squared anymore because we're thinking in 3D terms. It's actually centimeters cubed, which means that we're going to fill this shape with little centimeter by centimeter cubes. And how many of them could we fit in there? That's the idea. Now, some questions are not going to be as straightforward as that one, where it just gives you the area and says, here's the area, here's the depth, find it. Sometimes you have to find the area for yourself, like in this trapezium, trapezoidal prism, right? So I can see that the shape that's going to run through is a trapezium, right? If I were to cut this down here, that trapezoid shape would run through the middle of the whole shape. Because if I cut it down there, it's going to be sort of awkwardly shaped, right? Now, if I were to cut it here, it'd be different on either side, and you want it to be the same the whole way through. So we're going to go back to our formula for finding a trapezium, which is a half of a plus b, or a plus b divided by 2, whichever you prefer, times the height. And I'm stupidly left off the height, which is a very important part of this. So let me just make up a number here. I'll call that 6. Apologies for that, that was really dumb. Right, so that's the area for a trapezium. Let's find that out. So a half of a plus b, so 10 plus 17 is 27. We're looking for a half of 27, right? And we times that by 6. So a half of 27 is 13.5 times by 6. What's that, 78, 81, I think? Hopefully my quick maths is still good. Maybe I got that wrong. 13 times 6 is 78, and half of 6 is 3, so 81. So that works. All right, so we've got 81 as our area of our main shape. Now I need to times it by the depth to get the volume. So I've got 81 times by 9, which gives me 9 and 72, 729 centimeters cubed. All right, so that is the volume of this shape. That's how many like little centimeter by centimeter cubes I could use to fill up that whole shape. Okay, let's try one more. All right, this time I've got a triangular prism. Yeah, I'm just going to adjust my camera so you can see a little bit better. All right, triangular prism. My height is 12, my base is 8, my depth is 9. So again, I'm going to find the area of the shape that runs through, which in this case is a triangle. Right, that's the face. area of a triangle is the base times the height divided by 2, right? That's area for a triangle. So in this case, the base is 8, the height is 12, divide all that by 2. So 8 times 12 is 96. 96 divided by 2 gives you 48. You can put that in your calculator if you can't, if you don't want to do it that quickly. Times that by 9, which should give me 432, I think, if my mental maths is correct. 432 centimeters cubed. Quickly make sure I got that right. Yeah, good. Okay. So that is my volume for this shape. Again, feel free to use a calculator for any of this working out. The best thing about measurement is it's all about working with formulas, and you can use your calculator to solve any of them. Hopefully that clears up what you have to do. Thanks. Bye.